Welcome to Tantech's webinar on the automotive industry. My name is Jeff Gratis. I run the Tantech office in North America. We do all the sales and service out of our Chicago facility. Today's webinar will be touching on plasma and corona in the automotive industry. A lot of low surface energy plastics are used in automotive to help reduce weight in the automobile, but that in turn results in difficulty with adhesion, coating, and printing on these surfaces. Corona and plasma is commonly used in the automotive industry to help remove and eliminate the need for expensive and dangerous primers as well as flame treatment. As you might have experienced yourselves already, it's really difficult to get glues, inks, and coatings to stick to these plastics, and we'll touch on some of the experiences Tantech has had in the past to help improve this and provide additional value add to your products. So this slide here is going to go over why surface treatment is used and how to solve some of the adhesion problems. So one of the advantages that plasma and corona provides for you are even and uniform treatment across a three-dimensional object. This can be achieved with both atmospheric plasma, vacuum plasma, and corona treatment. It really all depends on the manufacturing process, the design, the technology, and the setup that we build into the system to ensure you get good quality uniform treatment across the entire part. This all starts and gets developed through the initial investigation phase to find out where on the part you need the treatment, how you're processing the parts, to see how a Tantech system can be implemented. As we just mentioned, we can treat specific locations on the part, or we can treat the entire part, and that will really determine which technology makes the most sense. Vacuum plasma, in many cases, designed to treat the entire part all across the entire surface, where corona or plasma might be a more focused and specific treatment area. Larger parts are typically done in a vacuum chamber, where you can put the entire part inside, press a button, and the entire part is treated. We can do larger surfaces as well with corona. Again, this is all determined during the investigation phase, finding out what makes the most sense for your application, how you're handling the parts, and we don't want to disrupt too much of your production process. We can also do cleaning on the surface as well. This is typically done with our atmospheric plasma system. This system is developed to provide a very high intensity ionized air blown out onto the surface. During this process, the combination of heat, air, and ions will actually clean off micro contaminants or organics from the surface, resulting in a nice surface to go ahead and bond to or print onto. One of the questions we're posed very regularly is, what does this do to my material? Does it affect the shape, size, integrity of the part? Corona and plasma surface treatment is a micro treatment, meaning we're just treating the top layer molecule of the plastic or metal in this case. So we don't really affect the surface of the part beyond that top layer. So the integrity of the part, the size of the part, the shape of the part is not affected by this treatment. The only thing we're doing is providing bonding sites to allow the glue or the coating or the adhesive to go ahead and stick better. So if you imagine plastic materials, the molecules are very tightly bonded together. What we're doing with surface treatment is trying to open up bonding sites. So you've got these microscopic peaks and valleys that allow your glue, coating, or ink to go ahead and wet out and attach itself to the surface. Another area that the corona and plasma provides a great deal of value is it's cost effective. Overall, on a typical day, you might be using electricity and a little bit of air in order to run one of our systems. So you're talking about only spending dollars per day to run a Tantech system, as opposed to a chemical primer or a natural gas solution with flame. The natural gas costs add up throughout the day, as well as the heat generated in the plant. And when it comes to primers and alternative gluing solutions, they tend to get rather expensive and very, very costly to run on a daily basis. These systems are also environmentally friendly, meaning we don't have any VOCs or those types of controls that we need to worry about that you tend to find with primers. VOCs are being outlawed from state to state, and regulations are becoming more stringent on that area. So please let us know if we can help with a corona or plasma solution that is certainly much more environmentally friendly. So some of the typical parts and applications we come across for the automotive industry, one of the big areas is interior trim parts. This is a product that typically is wrapped or coated in some way, and we've had a lot of success with interior trim parts in vacuum plasma, where these parts are then taken into a rack system, put inside the chamber, the door is closed, pressing a button, 3 to 5 minutes later, the entire surface is treated, which allows for proper wrapping and gluing of this part. As you might imagine, when you're manufacturing a nice high-end automobile, the last thing you want are interior trim parts peeling back or delaminating and resulting in warranty recalls or customer complaints. The other area, obviously, exterior parts, a lot of work with headlights, grills, door handles, side mirrors, just trying to adhere or glue specific areas as opposed to mechanically fastening. And again, in a lot of these cases, we're removing a primer process here to allow that part to go ahead and glue and stick to the door better, or the handle, or maybe a grill. Headlight sealing is very important with foam in place gasket. So we're making sure the integrity of the part lasts the length of the automobile. Another area that we've had some success in as well is using atmospheric plasma to treat powertrain parts. One of the things that we've seen in the industry is the move away from gaskets to more of a sealant being put down over the sealing area of the part. This is typically done with an atmospheric plasma that's passed over the surface, creating those functional groups on the surface and also cleaning the metal so that that sealer has the ability to go ahead and lock on and create a nice seal to provide any risk of leaking or anything along those lines. Another area that we've had some success in is profiles, EPDM profiles. So the coating and flocking process that's done on these to ensure that they're protected in the environment of heat and sunlight over the life of the car. We want to make sure these EPDM profiles don't become brittle and start to flake off. So flocking and coating is typically done here. Prior to that, we run a atmospheric plasma through the extrusion process. Parts are extruded, passed through, they're treated on the areas that are receiving the flock or the coating, so that this way when they're installed in the car, those areas that are coated are now protected in the installation process so that the material lasts the life of the automobile. Other areas we've had success in, obviously the introduction of safety features, front-facing cameras, rear-facing cameras, specialty mirrors, all of those areas where we're able to go ahead and apply a plasma or corona process to ensure the integrity of the adhesion to the surface that it's working on. As you might imagine, with the safety features that are built into these, it's very, very critical that they maintain a certain level of standard so that they can pass the stringent tests that the automotive industry is looking for. So this image you see on the slide here is a front grille cover. This is a part that has been treated prior to painting. And typically what's done with something like this is either a flame treatment or a primer if they have not gotten into a plasma or corona process. This can be done with both atmospheric plasma, vacuum plasma. Typically the entire part will be placed inside of a chamber, or an atmospheric plasma would then go across the surface in a robotic application to help improve the surface energy of these parts to improve the paint adhesion on a grille of this size. We talked a little bit about the automotive interior trim parts, and you can see a door panel here where there's a lot of parts that are going to be wrapped and glued. This is typically done again in a vacuum plasma based system. But another area that this touches on as well is if you want to seal this panel to the door itself, the backside, we can then go ahead and treat the perimeter panel where you would then dispense a foam in place gasket or some sort of adhesive into the channel itself to then go ahead and mount and glue against the door. This helps prevent water or moisture getting in between the panels and improving the integrity and life of the part itself. And we did talk a little bit about EPDM profiles. So these are some of the profiles that we've worked with over the years. Again, this is all about flocking and coating, flocking for the inside of the car and coating for the outside of the car to prevent against UV and heat extremes to ensure that this rubber material doesn't flake or become brittle over the life of the automobile. These are just a few of the applications that we work with. We certainly have the ability to take on multiple challenges in terms of three-dimensional objects, different types of materials. It's just best to reach out to us and get some information from you in order to understand what your struggle is and how Tantech can help. And this video here is going to simply show the before and after dyne test. This is a basic surface energy measurement process. What we're doing here is simply showing what a treated and untreated surface would look like. Typically with a plasma or corona surface treatment, you can't physically see any change to the part with the naked eye. You need this type of solution or potentially a contact angle solution to go ahead and measure the surface energy change, as well as obviously doing a functional test at the end to ensure that it's achieving the results you're looking for. Surface energy measurements are a fantastic way to determine that you've made a change to the surface, but ultimately doing your functional test is the right way to determine if that change in energy equates to the value add that you're looking for. So there are multiple technologies that Tantech works with in the automotive sector. One of the most popular is our atmospheric plasma system. Reason for this is it's typically following a dispense process. It can be very, very robot friendly, simply mounted on, following a predetermined path that your glue or your dispense of a gasket is then placed onto. Extremely user-friendly, very, very easy to operate, low cost, running on electricity and some compressed air, provides a great deal of value in terms of cleaning and surface treatment to a very, very high number in terms of dyne level. It's also used for the EPDM profiles. This is typically done on an extrusion line, so we can put multiple heads inside of a machine treating the extrusion as it goes by in the various areas that the coating needs to be done. We can also look at our vacuum plasma as a very popular product for the automotive industry as well. Reason being is a lot of the parts are large and complex in size, shape, and geometry. Not all the time are we focusing on a small area, we might be focusing on a larger area, and putting these parts inside of a chamber ensures that the parts are treated 360 degrees in a rather short period of time. Typically when people hear vacuum plasma, they get a little concerned because it's batch process, so they're worried about timing. Tantech typically can make a system that's large enough to ensure that we maintain your cycle time, or we can also look at our vacuum line, which is an automated or semi-automated vacuum plasma process. Parts are moved on a conveyor, the chamber doors open, part moves into a conveyor inside the chamber, the doors close, treatment takes place, doors drop down, part goes out to the exit conveyor at that point. What's great about this type of system, it provides complete process control. If the part entered the chamber and came out the chamber, that means the part was completely treated. If the part does not come out of the chamber, you have to check the Tantech system to see why the system did not allow the part to go through. So you can feel confident that once a part enters and comes out, it's been fully treated at that point. And then we do have some Corona-based systems as well. Our Tech is a very, very popular product for treating very, very specific areas for printing or gluing unique geometry parts in an inline process, or maybe even built onto a XYZ gantry type system. So Tantech has a variety of different technologies and systems available for treating different parts and applications. Please reach out to us. We can certainly help explain the different options you may have. There's certainly the good possibility that there's more than one option that can fit your process, fit your budget, and fit your overall expectations. So we've got a few cases here for you that we'll be able to send over to you after the webinar is over, talking a little bit about some of the chambers that have been provided in this particular case. This was provided to Grupo Antolin doing interior trim parts. As you can see, these are a large vacuum-based chamber with drawers on them. So the system allows for the operator to pull the drawer out, set the parts, push the drawer in, and then there's an auto door present that comes down to go ahead and close and seal off the door. The pumping takes place after about a minute and a half or so. The plasma will then ignite inside the chamber. Usually customers will run for 1 to 1.5 minutes inside the chamber, treating the entire part 360 degrees while it's sitting inside the chamber. Once repressurization takes place, then the door opens and the parts are able to be removed and sent on to their next process. This system here, you'll be able to check out this case study as well. This is what we call our profile tech. This is using our atmospheric plasma system in an extruded line, typically done on an EPDM profile or some sort of pipe or cabling that's used in the automotive industry, where we need to treat the exterior in various locations. So what's great about this system is the nozzles will come in a configuration of 2, 4, 6, 8, 10, 12, up to 20 nozzles that you can then go ahead and simply adjust and put into position where you want the treatment to take place. It's a very, very quick, easy system to use. Once the extrusion begins moving, the plasma turns on. When your extrusion stops, the plasma turns off. provides a great deal of improvement on the surface energy, as well as cleaning the part on a microscopic level as well as it passes through the plasma process.